Dear viewers, welcome and thank you for your support by subscribing our channel. In this example, let us see how to create the loads, namely dead load, live load, load combination for the 3D space frame which has been already created in the previous lecture. Now let us take that space frame which we have already created. So this is a space frame which we have already created, in which we are going to give the loads. So let us see about the loads. What are the loads which we are going to assign to this frame, and then we will assign. Okay? So the loads sections. So this is the frame. Say we have 4.5 meter, 4 meters and 6 meters, and vertically we have 2 meters, 4 meters, 3 meter, 3 meter and 3 meter. This is the frame which we are going to see. Now, with regard to the loads, say, first let us speak about dead loads. So, all the slabs, either it be roof slab or floor slab, let us calculate the self weight of slab. So, the self weight of slab should be considered as the dead load because it will be permanently available in a structure. So, the self weight of slabs shall be calculated using the unit weight of the material of the slab. So, preferably here probably here RCC slab is therefore unit weight of RCC multiplied by slab thickness. So any unit weight multiplied by thickness will give you load per meter squared area. So here unit weight of RCC is 25 kilonewton per meter cube, and let us assume thickness of slab as 0.15 meters or 150 mm. So 3.75 kilonewton per meter squared, both floor and roof slabs. And in this TAD, if we want to assign this, we need to mention the y range, that is along y axis. What is the distance of this or where it is spread over, the self weight is spread over. So if you see the diagram, say here, this is the ground floor and this is the roof slab of the ground floor, and likewise it will go the floor slab, and in the topmost we have roof slab. So the slab, say slab starts here, say this is ground floor, so 2 meters is from footing, so 2 meter plus 4 meter if you add the ground floor height including the basement, so 2 plus 4 6. So the floor slab starts here, say floor slab starts at a distance of 6 meters, and here we have the roof slab, so at a distance of say 6 plus 3 9 plus 3 12 plus 3 15. So the y range for slab weight will be should be considered as 6 meters to 15 meters. So likewise, we should calculate in every frame. Similarly, floor finish. So floor finish, we need to give only for the floor slabs. Floor finish will be giving for the floor slabs. When it comes to the roof slab, we'll have to calculate the weathering post, because over the roof slab we will be providing the weathering post. So floor finish, in this example it is assumed as 3.25 kilonewton per meter square. This value also we could exactly arrive by using the formula that self weight of the flooring material or unit weight of the flooring material multiplied by flooring thickness. So here we assume 3.25 kilonewton per meter square. And Y range will be, say, the floors, all the floor slabs. So the floor slab starts at 6 meters plus 3, 9 plus 12. So it ends here because this is roof slab. So floor slab will start from 6 meters and ends at 6 plus 3, 9 plus 3, 12. So it ends at 12 meters. So the Y range for this floor finish will be 6 meters to 12 meters. And weathering course, we have assumed 2.25 kilonewton per meter squared. And this, the Y range for this will be, we see the diagram, say 2 plus 4, 6, 6 plus 3, 9, 12, 15. So at the height of 15 meters, we have our floor slab. So the Y range will be 15, minimum also 15, the maximum also 15. Therefore, the Y range for this will be 15. So you can see here, the Y range will be 15 meters. Then, unit, if you want to calculate or see know about the unit weight of all materials, say if you use lime concrete or if you use brick-bat concrete for weathering post, similarly for flooring if you use granite or if you use marble. So the unit weight of all materials will be available in IS 875 Part 1. So using that, the self-weight, flow finish, weathering post can be exactly calculated. Now the wall load should also be considered as the dead load. So wall load we can calculate using, say if it is a 4 meter high wall, say 4 meter high wall we have here, say we have here this wall over this region will be the ground floor will be having 4 meters height. So the 4 meter wall height will be 20. 20 is the unit weight of wall material, say brick. So 20 kilonewton per meter cube into wall thickness multiplied by this 4 meter height will give you the uh, wall load per meter length. So 18.4, say you can make it as 20 kilonewton per meter is the wall load on the 4 meter high wall. And if it is 3 meter high wall, say 3 meter high wall will be all the other walls. Say this is 3 meter, 3 meter, and 3 meter. So all these three walls will wall loads will be resting on the respective beams below them. So to calculate 3 meter height, then 20 unit weight of brick multiplied by wall thickness multiplied by height. So 13.8, say 15 kilonewton per meter. Whereas the parapet wall, say here, at the roof slab, parapet wall will act over the periphery. So to calculate the weight of parapet wall, it will be 20 is the unit weight of material, brick material, and say here we have parapet wall. 0.23 is the wall thickness, and 1 meter height. Normally it will range from 0.8 to 1 meter or 1.2 so or so. So 20 into 0.23 to 1, therefore 4.6, say 5 kilonewton per meter. This is the wall load. In case if we have any partition walls in the building, then we need to calculate the unit weight of the material used for the partition wall multiplied by partition wall will be normally a half brick thick, say 0.115 meters multiplied by height. So that will be the weight of partition wall. So this is how we should calculate the. Similarly, when we talk about live load, for roof slab, it is 1.5 kilonewton per meter squared. And the Y range will be, as we have seen in this diagram, the roof slab is located at a height of 15 meters from the bottom. So 15 meters will be the Y range. And the Y range for floor slab will be 6 meters to 12 meters. So the floor slabs, the live load is 3 kilonewton per meter squared. And this is also available in IS 875 part 2. All the live loads, say live load on roof slab, floor slab, different floors, say it may be library. In the case of educational building, if classrooms, what will be the live load? For library, what will be the live load? Likewise, you can see from the IS 875 part 2. Now we shall go to assigning these loads in the Stratco space frame, which we have modeled already. So here we have already specified the supports also. Now loading. So go to the loading, click load case details, click add. Say first load be dead load. So type it as dead load, add, then let us take live. So type it as live load, add. So under dead load, we are going to add the sulfate of beams, columns, slabs and all. So let us see how we are going to add. So click dead load, click add. First select sulfide, so -1, click add. Then we will be giving the floor loads, that is all the sulfate of the slab, floor finish and weathering post need to be included in the dead load. So that shall be treated as floor load. That shall be called as floor load. So click floor load. So we have calculated the sulfate of the slab as -3.75, and the Y range that we have seen. Say the slabs start at a height of 6 meters and they end at the height of 15 meters. So Y range will be 6 to 15. Click add. Then we have floor finish. So floor finish we can calculate, or we can assume, we have assumed as 3.25, and the range will be 6 to 12 meters. 6 to 12 meters. Click add. And the weathering post we have assumed as -2.25. Y range will be, so since it is weathering post, it acts at the roof slab. So 15 is the minimum as well the maximum. So click add. Next, let us add the wall loads. So wall load will be treated as member load or UDL, uniform distributed load. So we have calculated wall loads as minus 20 kilonewton per meter, and then we have calculated minus 15 add, then we have calculated another wall load, there is a parapet wall as minus 5 add, then close. So in the under the classification of dead load, we have included self weight and we have included the self weight of slabs. This is the floor finish and this is the weathering post and these are the wall loads. Now we have added all these things, then we need to assign. Before that, let us add live load also. So click live load, click add. So live load, we have only two categories. That is only one is the roof slab and other the floor slab. So roof slab minus 1.5, and the Y range is, say roof slab is located at 15 meters. Similarly here, 15 meters. Click add. Then all the other floor slabs we have minus 3. So range, Y range will be slabs start at 6 meters and the floor slabs end at 12 meters. So click add, click close. So this is how we should add all the loads. Now let us assign one by one. So click self weight, select all the members, that is beams and columns. Click assign to selected beams, click assign, click yes. So this step will calculate the self weight of all beams and columns. Now if you click on any load, it will display. Say this is the self weight of slab. So say it starts from say ground floor roof slab, first floor roof slab, second floor roof slab, third floor roof slab. So all the things we can see what are the loads assigned. Now this is the floor load. So range we have specified, so it will act this. Similarly, this is the weathering post load. So if you want to see only that, then we can choose the option. Say go to view, go to display options, go to assign dialogues, and show the labels for selected item only. Click apply, OK. Then it will display only that load. Now we need to give the wall loads. So wall load minus 20 is applied, should be applied on the 4 mid height wall, that is in the all the plinth beams. So to cut the plinth beams, we can use cut section option. So before that, let us switch on the node numbers so that we can have the cut section correctly. So let us cut at the plinth beam level. So at 5, so go to utilities, go to beam tools, structure tools, cut section. We need to cut at the level of XZ, say at the node point 5, so that we can have a cut section at this level. Then select this load. This need to be applied on the ground floor beams, okay, or the ground floor plinth beams, on the plinth beams. So here we will be having the plan. So having the plan in hand, we can apply this wall load wherever wall comes. Say if I have walls here acting over this plinth beam, this plinth beam, this plinth beam. Outer will be definitely having, because we'll be having walls on the periphery necessarily or compulsorily, and inner walls that has to be applied depending upon the plan. Say if I don't have a wall here, then I can skip that. I can add only here. If I have wall here, I can add, or I can skip. If there is no wall, I can skip. So wherever wall is available, is add. So that we need to give only the load where wall is available. We can skip wherever it's not available. So otherwise it will be unnecessarily overloaded. So that should be avoided. So click assign. Click assign to selected beams and click assign. The wall load will be applied over to this. Now go to view, go to display whole structure. The whole structure will be visible. You can see the loading diagram also. So it will be this wall load available applied on the plinth beams. Now we'll apply these loads, the wall load 15 on the, say, this beam, this beam, this beam, and this beam. And here we need to apply the parapet wall load. So let us make cut sections at the level of 9, 13 and 17. So using the option utilities, structure tools, go to cut section, the XZ plane, we'll choose at the level of 9. So click OK. So when we are giving this cut section is, we can select which are the beams where we have walls. Otherwise, we have other options also to give wall loads. But here, this will help according to the plan. Say if the ground floor plan is different, the first floor is different, second floor is different. This option will be exactly useful for assigning the wall loads. Say let us assign wall loads over here, say here, here. External walls, there will be all the walls should be included because we'll be having walls on the periphery definitely, and only the internal walls depending upon the plan. Say let me have the plan like this. I will have the wall here, I will have wall here, and I will have wall here, wall here. So like this we have. Then click to assign, select beams, click assign, click yes. So this 15 is applied. Now view the whole structure. So view display whole structure. Now we have applied a wall load here. Now 13, at the level of 13 I need to cut. So go to utilities, go to structure tools, cut section, say at the level of 13. So XZ 13, click OK. Now choose this load. It need to be applied over the, so all the outer walls necessarily we need to apply as I told earlier. And inner walls depending upon the plan. Say the plan might be different here now. So only this. So click assign, click yes. Then view, display, whole structure. If the plan is same, then we can have other options. The plan is different, then we need to do like this. So let us, in this example, let us see that plan are different at each level. So that's why I'm doing this option. Now cut at this level, say at 17 or 45, you can cut at this level. So go to utilities, go to structure tools, cut section, XZ plane, say let it be 17. So it is cut at this level, 17 level, so minus 15. So it is applied like this. They have walls only like this, so it can apply like this, click assign. So this depends on the plan which we have. Then click view, display whole structure. Now the only thing is parapet wall, so click outside. So we need to select at the level of 21. So go to utilities, go to structure tools, go to cut section at the level of 21. Okay, then take this minus 5, and this has to be parapet wall won't be available on the periphery alone. So we have parapet wall only on the extreme ends. So select all the things, then click assign to selected beams, click assign, click yes. Now view, display, whole structure. So you can check here. So we have assigned self-weight, and all the floor loads will be assigned by itself. The wall loads we have assigned. The floor load, live load, this also will be assigned by itself. You click and see whether this is the roof floor load and this is the floor slabs. So this. Then the next is we need to give the load combination. So go to load case details, click add. 3 will be define combination, okay, or auto load combination. Go for auto load combination. You can select the IS 456 code, IS 456 or IS 800, generate loads. So this is the load combination. Click add, click close. So we have the load combination. So third will be 1.5 dead load plus 1.5 live load, and fourth combination is 1.2 times dead load plus 1.2 live load. Fifth combination is 1.5 times dead load, and sixth combination will be 0.9 times dead load as per the IS 456 code. So this is how we should apply the load over the frame. Then analysis, click analysis, go to analysis commands, click perform analysis, click all, click add, close, then design. So click design, select all the members, select complete, choose IS426 code, select parameters, bring all the parameters this side. So we need to choose FC, press Control, FI main, FI secondary, maximum main, maximum secondary, and then minimum main, minimum secondary, minimum main, minimum secondary, bring this side, click OK, define parameters, FC, say the value will be 20,000, click assign, then FI main, say let it be 415 steel, so 415,000, assign, FI secondary, say 415 grade steel, so 415,000, assign. Then maximum main reinforcement, say let it be restricted to 20 mm, and maximum secondary reinforcement 12 mm, minimum main it should be 12 mm, click assign, minimum secondary 8 mm, assign, close. Now go to select beams parallel to X, select beams parallel to Z, all the beams will be selected, go to commands, design beam, assign, close. Now select all the columns by clicking beams parallel to Y, all the columns will be selected. Go to commands, design column, click assign, close. Now select everything by passing a window, then commands, take off, click assign, close. Now the pre-processing is completely over. So initially in the first part we created the geometry, we assigned the support specifications, and in this part also the member properties were given in the earlier part, and in this part we have given loading, analysis command and design command. Now it is time to analyze or do the processing. So click run analysis, click save.